dividing example. So determine the quotient. So the quotient is the word that means the answer when you divide. Don't forget that. You have to know that. Product is the answer after you multiply, right? Sum and difference are obviously from adding and subtracting. And then identify your non-permissible values. Okay, so dividing. Same thing as before. We would factor your numerator and denominator. Okay. Then you would change division to multiplication and use reciprocal rational expression after division symbol. Okay, or you could just put multiply by the reciprocal if you do 11. Okay. Now that it's multiplication, you can extend out your fraction line. Okay. So numerator times numerator now, denominator times denominator now, or extend fraction line. Okay. Cancel factors. And then always give your non-permissible values. Okay? So fraction or factor your numerator and denominator, change your division to multiplication and make sure you use the reciprocal. Now you can now it's multiply times multiplies. Sorry, it's just multiply, so you can do numerator times numerator, denominator times denominator, or extend out that fraction line. Then you can cancel your factors, and then you have your non-permissible values. So much like the other one. Okay, so let's take a look at this top one. X squared minus 4. What are the factors of x squared minus 4? Help me out. Not x squared, but x minus 2, x plus 2. You're right. Okay, denominator there. Not difference of squares. We almost got caught on that one in the last example because that x isn't squared, but there is a greatest common factor. What is it? X. Good. So you have an x, and then the leftover would be an x minus 4. Okay, we have division here. I'm going to leave my division in for now because I'm still in the first step where I'm factoring the numerators and denominators. What are the factors of this second rational expression's numerator? X what and x what? 3 and 2, which one's minus, which one's plus? Good. Plus 3, so you need more positives, minus 2. Okay, denominator. What are those factors? X what and x what? 4 and 5, which one's positive? So we want more positives. Plus 5, good. Oops, and then minus 4. Hopefully your factoring is going a little faster now. When we first did it in chapter 4, after having the whole summer off and not doing it since grade 10, it was slow, but these ones should be fast, getting faster. Okay, I am going to change this division to be multiplication. I'm going to keep my first one the same, x minus 2, x plus 2, over x bracket x minus 4. But when I change this one to multiplication, these switch. So my denominator becomes my numerator, and my numerator becomes my denominator. Okay? Now it's multiplication, just like the last example. Numerator times numerator, denominator times denominator, or I can consider this now that it's multiplication, I just extend out my fraction line, start canceling stuff. So, what factors cancel? X minus 2, good. X minus 4, good. And that's it. So, whatever's left, x plus 2 and an x plus 5 are on the top. And on the bottom, what's left? X and then x plus 3. You are allowed to leave it this way. You don't have to distribute it back out. Okay? But I have to list my non-permissible values, so I go back up. Now this one's a little tricky Non-permissible values come from denominator and from a numerator after division. Okay, so that was a little tricky. Normally you'd look at this and you'd say, okay, my denominators were here at the beginning and here, so that would be a 0 and a 4. Here, which would be a -5, and here, which would be a 4 again, so I don't have to list 4 twice. Okay, and that looks like it should be it. However, remember, this fraction up here, it's okay to have a 0 on the top, because a 0 on the top of a rational expression is allowed. But what is 0 divided by anything? 0. And then you're dividing by 0, which is not allowed. Do you see how that works? So, if you see, it's always a division symbol. So, the fraction line is a division symbol, so that's why we're checking these ones that are underneath. Fraction line is really a division symbol, so I'm checking these that are underneath. This is a division, so I do have to check those two on top as well. So now I actually have extra ones, and they are -3 and 2. Okay, so -3 and 2. Another reason is why is because when you go down here, you see how they do become part of the denominator. Okay, so they did switch to become a denominator in that